Welcome to Bright Minds. I am the Seeker. I seek the truth about reality. In the last video, What is Evidence?, I talked about evidence and how it justifies belief in different hypotheses. That leads me to today's video, which is about how to adjust the certainty or probability of a certain belief in the light of new evidence. How do we adjust the probability of the truth of a certain hypothesis? How do we choose which hypothesis best explains the evidence? We're going to go a bit into Bayesianism and the laws of probability. Don't worry, this is a brief discussion, and there won't be too complicated math. Bayesianism is named after Thomas Bayes, whose formula is the core of Bayesian thinking. First, let's take a look at some laws of probability and see how we can arrive at Bayes' formula from there. Let's assume that we have a box in which we have balls. The balls are either white or black, and each carries a letter, either A or B. So we have a combination of four possibilities: white A balls, black A balls, white B balls, and black B balls. We can represent the different possibilities using a Venn diagram with four regions: white and B, black and A, white and A, black and B. The area of each region represents its probability. Now let's introduce conditional probabilities. What is the probability that it is an A ball given that we know it's a white ball? This region is the white balls. Knowing that the ball is white, what's the probability that it is also A? It's the probability that it's white and A relative to the probability that it is white. So we divide the probability of white and A by the probability of white. Now, let's multiply both sides by the probability of white and we get this. The probability of white and A is the probability of A given white multiplied by the probability of white. Now let's look at another conditional probability. What is the probability that it is white given that it is A? It's the probability of white and A relative to the probability of A. So we have the probability of white given it is A equals the probability it is white and A divided by the probability it is A. Now multiply each side by the probability of A and we have the probability of white and A equals the probability of white given A multiplied by the probability it is A. Notice that we can calculate white and A two ways, either by A given white multiplied by white, or by white given A multiplied by A. Therefore, those two expressions are equal. From that, we can divide both sides by white and we get this. The probability of A given white equals the probability of white given A multiplied by the probability of A, all divided by the probability of white. That, ladies and gentlemen, is Bayes' formula, the core of Bayesianism. Now let's modify it a bit to make it ready for application to evidence and hypotheses. Let's change white to evidence E and A to hypothesis H, and we have the probability of the hypothesis H given the evidence E equals the probability of evidence E given that the hypothesis H is true, multiplied by the probability of the hypothesis H, all divided by the probability of the evidence E. In other words, to adjust the probability of the hypothesis H in light of new evidence E, we assume that hypothesis H is true and see how likely it is to find evidence E given that H is true, which is called the likelihood of the evidence assuming the hypothesis is true. We multiply that by the prior probability of the hypothesis H, which can be thought of as the current state of knowledge regarding the hypothesis H. And we divide all by the probability of the evidence E showing up no matter what hypothesis is correct. From this, we learn something very important in Bayesian thinking. The likelihood of the evidence is not the credence of the hypothesis. I repeat, the likelihood of the evidence under the hypothesis in question is not the credence of said hypothesis. For the credence of the hypothesis, we also take into consideration the prior probability of the hypothesis being true relative to the probability that the evidence shows up in general. The probability of the evidence E in general is the probability of the evidence given the hypothesis multiplied by the prior probability of the hypothesis plus the probability of the evidence E given the alternative hypothesis multiplied by the probability of the alternative. And we do that to all the alternatives, thus we arrive at Bayes' formula in its most elegant form. In future videos, we can see the application of this elegant formula to the hypotheses and new evidence, and we can use it to figure out which hypothesis is more likely and by how much when considering two competing hypotheses. I am sorry if this video was a bit hard and dry and full of math. Nevertheless, if you like this video, please don't forget to like and share with others and to subscribe to my channel if you haven't already done so. Click the bell button too to know about my videos as soon as they are out. As always, until we meet in the next video, be safe and stay curious.